All right, I'm going to begin with a kind of overview of the type of data that we'll be using in these projects. And most of the data initially comes in the form of sequence data, which is typically found inside something called a FASTA file. So I'm going to kind of give you an overview of what a FASTA file is and how you structure one. So a FASTA file is always going to start with a greater than sign. This is just a regular text file. So I am in a general text area, text application, similar to Notepad, or preferably if you're on Windows, you can, of course, it comes with Notepad. You could also use Notepad++, which has some superior features. It's free and you can download it. Do not use Word and do not use WordPad most of the time because those two programs add additional pieces to the actual document that cannot be read by many of the bioinformatics programs. So you want to make sure you use Notepad if you are in Windows, and you need to save it as a text file. And if you use Notepad, it will actually save it as a text file. So to begin with, a FASTA file always begins with a greater than sign, and then this first line is reserved for you to name it or give some description of your file. So I'm just going to call this my test FASTA file for this review. All right, and so the first line can pretty much be anything you want. It should describe what you're doing. So then the second line, after you give your kind of description, you usually end up with where you put the sequence letters. Now, those of you who know something about biology know that DNA, it comes in four bases, four letters that represent chemical bases, and it's a sequence. It's a long linear sequence of these chemical residues. Actually, not residues. That would be amino acids. But in nucleic acids, like we're using, we can call them just bases. And so they are A, G, C, and T in any order here. And this keeps going. All right. You may run into some ends. That's when the sequence is unknown. And some programs cannot read ends. You have to take them out. But for the most part, you're okay. Most of the modern programs can read an in and understand what it is. Some of the older programs will not know what an in is, and you'll have to actually cut your ends out to get the program to just read it. Now, these letters here go on, and there is an old FASTA format. This is not true of all programs, but some of them only read up to 80 characters. Others read to 70, and others read each line as long as you want to go. So if I keep going here, I could make this infinitely long here, and within normal limits, it would be able to read it. Now notice I am using capital letters. Most programs would be able to read this sequence without a problem. There are those that require these lines to be 70 or 80 characters long. But these days, almost all of them can just read it straight. So you're actually fine here with this sequence for most programs. Of course, the issue is it's long and hard to read, and it would be nice if it were in an order where it was 70 or 80 characters. So if you're going to do that, staying within your program, 9, 10, 11, 12, 13, 14, let me count these. All right, this is about 70. It may not be right. If you're doing this for real, of course, be accurate. And you can cut this down. Oops, see, now I'm off there by one. And you could kind of move these so that they are in rows of 70 or 80. And this would make a legitimate FASTA file for most programs. Most of the modern programs can read a FASTA file in any way you put it, and the carriage returns that make a new line it will ignore them and just can see this as one contiguous sequence. Now, you can put more than one sequence within a FASTA file. You can skip down, it'll look at the space here, and I can go several spaces down, and I can go, this is sequence 2, all right, and I can put another sequence in here, etc. And I can go down, and it doesn't matter the distance. I can put another one, and start here. Oops, no V's. All right, and here's another one. So this is a FASTA file with multiple sequences. Really old programs may not be able to read multiple sequences. They may only be able to read one at a time. Most modern programs, if you do anything close to this, it'll figure it out. It can be any length per line. It can have more than one sequence, all of that. But as a general rule, if you want to make this nice and pretty, you should skip one space. That probably is not good. You need to skip one. That makes it easier to read. You need to go to 70 or 80 bases out here. Also helps with the readability of the individual sequences. But none of those things are required. You could leave it as one long sequence, and that would be fine, at least for most of the modern programs. So when we go to save this, I can go File, Save As, and I need to give it a name. Maybe I'll go 3 test sequences, something like that. Maybe I capitalize this to 3 test sequence, and then you save it as a .fasta, like that. So it must have the extension as FASTA. Sometimes FA works or FAS works depending on the program. But if you put FASTA, it's almost always going to be recognized by the program. And I save this. Now this program always saves it as in text format. If you use Word or something like that, it may not save it as a text format, even if you tell it to save it as a text format. Word is notorious for adding things in there that the old programs cannot read, so you have to use Notepad. So I'm warning you many, many times here that when you're creating your own FASTAs or you're editing FASTAs that you've downloaded, you need to use Notepad if you're in Windows. In Linux, like I'm in, these programs are compatible with this format, because most of the early people who were doing this and designing the FASTA used Unix. Linux is essentially the same in the modern day, and they have tools that are very similar and behave the same way. Windows is the problem with using many of the programs in modern day. All right, so this is a general introduction to FASTA files.